when exposed to fire. We have placed the cylinders above a tray containing a flammable liquid, providing an external source of fire. We perform the first test on a steel cylinder. Initially, the liquefied gas inside the cylinder absorbs most of the heat. The vapor phase of the LPG heats up faster than the liquid phase. It is the liquid phase that acts to keep that part of the cylinder cool for longer. But as the fire gets going, heat is transferred through the cylinder wall. It heats the liquid, which starts to boil, which in turn increases the pressure inside the cylinder. The heat from the fire starts to weaken that part of the cylinder wall above the top of the liquid. Soon the cylinder starts to bulge, indicating that the steel will soon succumb and the cylinder will rupture. As you can see, the gas flows out and ignites immediately, causing a violent explosion, a so-called boiling liquid expanding vapor explosion, or BLEVE. Now, let's perform exactly the same test with a composite LPG cylinder from Hexagon Ragasco. The result is completely different. Since the composite material shields the gas from the heat, the pressure inside the cylinder rises very slowly. This means that the plastic casing starts to melt long before the pressure becomes high enough to rupture the cylinder. The resin in the composite also starts to burn, exposing the fiberglass wrapping. The heat soon melts the interior plastic liner, and the gas escapes through the fiberglass mesh. This continues until all the LPG is released from the cylinder, leaving only the plastic and resin residues burning slowly. The residues from the fire consist of pure fiberglass, mostly in its original structure. The same happens when several composite cylinders are stored together. 96 composite LPG cylinders from Hexagon Ragasco are placed in a cage and exposed to fire from an external source. The gas burns in a controlled manner that prevents the development of a serious explosion or BLEVE.